Hi, everybody. I'm so glad to be here today and to talk about transformers and HPC benchmarking. So we will see like two big parts today. The first part will be more about like Hugging Face and how we build like transformers. And the second one will be more about like benchmarking HPC and the challenges behind this. So before that, I would like to know more about you. Do you know transformers architecture? I cannot see you, but yes, that's pretty cool. So I will go fast on this part, and I will take more time about the benchmarking. So let's go. So you already know that Transformer is not like the movie from Michael Bay. This image, by the way, this image has been created by a model which is called Stable Diffusion, which is available on the hub, on the space. So back in the past, what happened? First of all, a paper from Google, which is called Attention is All You Need, in 2017. So it was kind of a revolution to explain the transformer architecture and to be able to kind of have a pre-trained model and to be able to fine-tune it. So it was just the beginning of like a new, just for me, a deep learning 2.0. So, and then 1 year later, they open sourced BERT. And BERT is a model that you can, as a transformer model, you can pre-train it and you can fine-tune. So it's kind of a revolution because you don't have to train a model from scratch. You can like create tons of models regarding your needs. And it was very new in the area. And a little of caveat is that we have like tons of models that are created. And it's some kind of the wild west of open source. So you don't know which model to use. You don't know if they have the same API. You don't have any documentation. So we were like, how can we improve it? So we started from the ground. We started with a transformer library, which is well known, with the form pre-trained method. And here is a GitHub address if you want to have a look or just to use it. So the idea is to ease the access to the transformers model and to have some kind of unification of the models and the usage and to be able to fine-tune them easily. So it wasn't enough because we had like to build a platform and we created the hub. So we will head into like what our model into the hub. So here is a model page on the left. On the left, and you can see like some tags that allows you like to choose the right model regarding the task that you want to do. And if you remember what I said about like all the models that are different, it's kind of very easy to pick the right model, but it wasn't enough. So we worked on the model card. You can see here it's a GPT-2. You have some kind of explanation about the model, how it was created, what are the metrics of the model. And at the top, you can see like all the tags. And you can see the transformer tag in order to say the compatibility with the transformer library as well. And on the right, we have like an inference API. I could like talk about it for hours, but the idea is just to easily try the model. Behind the scene, it's very complicated to have so many models that are loaded on an API. But anyway, let's move to datasets. So we saw models, and let's go to dataset. If you want to fine-tune a model, you need a dataset. You can use a dataset that is available on Hugging Face, or you can create your own dataset. So if we have a look like maybe a little bit deeper in the dataset, here is an example of the dataset. You can see, again, all the tags, and you have like a view, some kind of dataset viewer in order to view what's inside the dataset. And it's not so easy because sometimes we have millions of lines, and we have some statistics about the columns and the categories and all the stuff. That's very useful when you are looking for the right dataset and to pick up the right tags. I didn't say a word regarding the number of datasets, the number of models. But if you noticed in the previous slide, like in this one, yep, we only had like maybe 1,000.5 dataset. And right now, we have 70,000 dataset. And regarding the number of models, it's increasing like every day, more than 300,000 models. So we saw the models, we saw the dataset, and we are ready to go to train a model because that's what we will do with an HPC. But I will explain a little bit more during the benchmark of the high-performance computer. So we will say that we created a model. It was very easy, thanks to the transformer library. So what should I do now? It's a good question. Some people are like, I will deploy it. I will do some inference. But we were thinking about something else. Yeah, because it's some kind of complicated when you are like, should I deploy it? Should I validate it? And we were like, okay, let's create a demo. But I'm not like a front-end engineer, unfortunately. I'm more like a back-end engineer. I'm more like working on stacks behind the UI. So 2 years ago, we acquired a company which is called Gradio. It's an open source company. You can have a look at like the link. And if you want to build like a demo, it's very convenient to do it. Like this demo, you want to compare two models? Here we go. So here is just an example of like a sentence and to see the result. And behind the scene, the code is pretty easy. All the lines, they are more related to some examples. And it's very easy to build in Python a quick demo. So we created a demo. We are ready to go. Maybe not. Because maybe you are working with a community. Maybe you are working in a company. And you want to kind of not deploy it on your laptop. You want to deploy it in the cloud. So we continue to work again. And we created spaces. I remember when I started at Hugging Face 2 years ago, we had like maybe 300 pods, 300 spaces that were running on our infrastructure. And right now we have more than 30,000 spaces that are running. And everything is crazy regarding all the numbers. So here is an example of some famous spaces. You can have a look, always a link. And what is important for us is like to abstract the complexity of things, abstract the complexity of like defining what is the right model, what is the right data set, how to deploy it in the cloud. So that's why we kind of abstract the complexity with GPUs, TPUs, accelerators, HPUs, and you just have to click, and here you are ready to go to deploy your space. And it's free. If you want to like just deploy a CPU, a demo, you can do it with, nothing. So at the end of the day, when the data set, the model has been created and the demo has been validated, you are ready to go to deploy it in production. So that's why we created like inference endpoint. We were like, okay, I need to scale up, scale down, automatically scale regarding the number of requests that we have. And we want it to be like one-click button. You just have to pick the model. It can be a private model. It can be a public model. And you are ready to go. But it wasn't enough. So we continue to work, especially with the open source community. So we created text generation inference. We were like, okay, that's awesome. I call it TGI. But sometimes people, they want to deploy it on their own infrastructure. So again, with just one model and one Docker command, you're ready to go to deploy your model. And it will abstract the complexity of the nickel stacks. And it will allow you to deploy big models on different GPUs. What is complicated currently regarding like big models? You need big GPUs with a lot of RAM. So I will talk a little bit about NCCL, which is called nickel. So the idea is that we will shard the memory for you. Imagine that you want, and you need for this model 80 gigabytes of RAM, but you don't have a GPU with 80 gigabytes of RAM. You have 4 GPUs with 20 gigabytes of RAM. And it will abstract you the complexity of the infrastructure behind the scene. So it's kind of pretty cool. So in the end, are we done? What is the role of Hugging Face again? And we started to work on model, an open sourcing model. And I would like to introduce what we did with Bloom. So Bloom is from the Big Science Initiative. I mean, we work with the community to create some kind of foundation model. So we were like, OK, it was back 3 years ago. We were working with the community to create the data set and to train a model. So we started to work on an HPC cluster. This HPC cluster used for this model was Jean Zay. And Jean Zay is a French HPC. So it was very good for us because we had a good knowledge of what to do, of what not to do with an HPC, and how to train a model on HPC. So at the end of the day, we were like, that was pretty cool to train a model. I mean, what was also a little bit complicated when you want to train a big model like a Bloom, like a 170 billions of parameter model, you need to do it. You need to do some distributed training. It means that we will do it on many, many GPUs, on many, many nodes at the same time. But I will have more details about it just a little bit later. So at the end of the day, we were like, OK, let's acquire our own HPC. And it was my mission to do it. So it was like, what is the best performance price ratio for an HPC in the world? So what I did, before that, I won't explain all the results, unfortunately, because they are all under NDA. But I will explain what I did with Scaleway. Yeah, on their own HPC. It's just here. So it's the introduction of the HPC of Scaleway, NABU 2023, which is a DGX superpod. And if you have a look at the photo of the HPC, there's a lot of servers, a lot of GGX that are connected together. And what is very important when you are training large model and you are doing some distributed training is the communication between GPUs. So back to nickel again. So when you are doing a distributed training, you have to communicate between 2 iterations. You have many iterations during the training. And at each iteration, you will have all reduce. That means that all the GPUs will communicate together and to share their results. So it's some kind of a big problem because it will some kind of block the scalability of the cluster. So that's why on the NABU HPC, I started with an all-reduce benchmark just to see how it will go. So here is some lines of Python. You can find it on the internet. It's not very complicated to find or reduce. And why did I do this in Python? Because you can use some methods with nickel, and you already have the benchmark. But we wanted to have the library, the environment, the Conda environment, in order to have the same condition of the training. Because sometimes when you are launching a training, you don't have good results, and you don't know where is the problem. You're like, what is wrong with my training job? And sometimes it's in the environment. So let's go with some Python script, some environment, and we are ready to go. And what happened? I was like, well, I can show you a little bit more because I know this slide. The results are not good at all. It's supposed to be 3.2 terabytes per second. So it's lower than anything. So I was like, what is wrong? Is it my code? Nope, because I already ran it. Is it my environment? For sure. What should I do? So I contacted NVIDIA, and they were like, oh, you are using a superpod, so you need to use containers. Like, what? And it was mandatory to use containers. So that's what I did. I started to write like a Docker file for my Python script in the end with my environment that is like inside the container. So for me, that's a good idea and a bad idea at the same time. Because when you have to build a container, it can take time. You have to push it on the registry. You have to pull it from the registry. And if you don't have like all the infrastructure, all the knowledge to do it, it can be tricky. But we did it. So, but it wasn't enough because I have my container. How can I run it? So I didn't explain a little bit later, but I mean, not all the HPC, but in some kind of like, or I can say all the HPC are running under Slurm. So here is a Slurm job that I created for my container. On the top, you can see like some variables that are very, very important. If you don't have those variables, it won't work at all. You will have like bad results like I had. And what is also very important is like excluding some InfiniBand interfaces. It was very important because those ones are related to storage. Otherwise, your traffic between GPUs will be shared with the storage, and you won't have good performances. And what was also very important is here to mount the InfiniBand. So we have nickel, but behind the scene, we have some kind of infra in order to kind of manage the network. Because having so many good performances, so much good performances on the network, it's a hard work, definitely. So, and what happened? It worked. And we are ready to go for the training. Because otherwise, it's my personal advice. When people are working on an HPC, you should always, and GPUs, and training, and distributed training, you should always do this in order to know the performances, the bandwidth, the throughput of the network between GPUs. So we are ready to go for like, what should I do now? I need to, again, I know, here are the result of the all reduce, my bad. I didn't do like all the, it's very important. So I will take a little bit of time for it. It's very important to check the scalability of the all reduce. Because as you are adding more and more nodes, the throughput will be reduced as well. And as I said before, if you reduce the throughput of all reduce, you will reduce the performances of the benchmark of the training as well. So I didn't finish because I was very busy at doing all the stuff, and I needed to train my model and to see the number of T-flops. So that's what I did. And again, I started to containerize my code. And it's not so easy to do it, because if you remember what I did with AllReduce, I was like, I have like tons of libraries to import into my container as well. And maybe one of the most complicated one was Apex. And so I had to manage how to do it and to work around it to find a solution for it. But it's not the only one. Flash attention can also be very tricky to put into a container. So here we are with the container and ready to go, and we train the model. So here are an example of like what we see when we are training a model. We can see like the number of T-flops per GPU. And what is a little bit funny is we have two types of T-flop, because sometimes we don't agree on the formula of T-flops, because it's mainly related to the number of tokens that the model is able to train. And it's more like when we want to compute the number of T-flops, we have to take the number of tokens per second per GPU, and we have to take care about the size of the model and the architecture of the model. Even if as the architecture are kind of common, we are more taking care about like the size of the model. Anyway, so back to the training, back to the benchmark. I did it on different types of different number of nodes. So that's what I did. We can see also the parameters that I used, like the data parallelism, the pipeline parallelism. And I did it on 4, 8, 16, 32, 64 nodes. And you can see that the number of T-flops is some kind of decreasing, but it's okay, because it's more like related to the fact that our GPU are communicating together, and we are adding more and more GPUs. Remember that on one node, we have 8 GPUs. So when we are doubling, it's like going crazy. So at the end of the day, what is our goal regarding the benchmarking? Is we want to be sure if we have like a supercomputer like the Nabu one, and if we want to use like all the nodes together, I mean the Nabu computer has 128 nodes in parallel, and we want to be sure that it's worth it. We want to be sure that it's good to scale it, because if you don't have the right network behind the GPU, you should like just wait more. And I remember that I didn't talk about like this one. Where is it? And the creating. Oh, no, it's here. Where is the star coder? I don't see it. Maybe I didn't push it on my. Yeah. Anyway, I trained star coder. I mean, it's not like the purpose of the presentation to talk about the models that I train, but it's still interesting to talk about, because we created star coder as we created like Bloom. It's some kind of the same. And the idea to propose like open source model to share it with the community. And for the star coder, you can have a look on huggingface.co, and you will have like the explanation of the model. And the idea of star coder is to generate some code. So yeah. And what I did it too again on the HPC cluster, because we created star coder once, and we are working together in order to have a better model right now. So that's why I did this benchmark with star coder, and I already knew like the performances of the model. It's better to have like some kind of comparison points when you are doing some benchmarks. So anyway, I'm kind of no, it was in the wrong way. Just a little word to finish. It's some kind of we are hiring some people, so it's not so easy to find the right person, especially with our culture, our way to work. So feel free to have a look at our workable. We are hiring, and you can see like all the positions that are open. Thank you, and I'm ready for the QA. Feel free if you have any question, just raise your hand.
Don't be shy. Oh, good job. I'm gonna come, sorry, because we're in live streaming. We will need you to talk in the mic. Thank you so much. Here you go.
Thank you very much for the presentation. And you got me hooked. What was the performance of the training? Like, how did it go?
What was the clue? They are good. They are good. And it's always like very complicated when we have some performances. I'm always like discussing. I didn't. It was at the beginning of the presentation. I'm in charge of the infrastructure. I'm not in charge of the training of the job and the performances. I'm more like in charge of everything around the training. So we had like a lot of discussion with the team, because sometimes they are like, it's due to the network. And sometimes I'm like, maybe it's due to your parameters. And sometimes it's due to some variables that we can optimize due to the length of the message between the GPU. So yeah, but they are good. Very.
So we have another question coming up. Please, thank you.
Hello.
Hello.
OpenAI made the recent move on distribution with the GPTs and the app stores. Do you plan to make this kind of move?
Sorry, I didn't understand the...
You know, OpenAI made a move to GPTs with an app store, with a business model to distribute AIs. Do you plan to make this kind of move with a business model and distribution?
We will still be an open source company. I mean, from the beginning of my presentation, yeah, I know that OpenAI, in the beginning, they were like an open company and working on open source. But in a sense, every step that we are doing, even if we are building a product, we are building like an open source project at the same time. So we won't stop to do it, even if it's, yeah, we have to take care about what people are doing with their models, and we are here to help. I didn't talk about like many things like what we are doing with companies in order to help them to have good performances with transformers, and I didn't explain what we are doing on ethics side too. But if I'm talking about everything, I will take too much time. Sorry.
We have more time for questions. One more. Okay, if we don't have questions.
Yeah. Thanks a lot, and you.
Thank you so much.
Yeah, and feel free to come and to see me if you have questions, if you want to discuss. Yeah. Thank you.
Thank you, Guillaume. Best one yet, in my opinion. Next up, we have a panel talk on reinforcement learning. So join us again at 4:10. Thank you.